Hey everyone! Welcome back to Syntax Grid, your go-to channel for all things machine learning and data science. Today, we're diving deep into one of the most powerful and widely used ML algorithms, random forest. So, make sure to stick around till the end. What is random forest? Imagine asking multiple experts the same question and taking their collective opinion rather than relying on just one. That's exactly how random forest works. It's an ensemble learning algorithm that combines multiple decision trees to make better, more stable predictions. Instead of a single decision tree, random forest builds multiple trees and then averages the results for regression or takes a majority vote for classification. Why does this matter? Because individual decision trees tend to overfit, while random forest reduces this issue and makes much more accurate and reliable predictions. Mathematical explanation of random forest. Random forest builds multiple decision trees based on the bagging, bootstrap aggregation technique. 1. Bootstrap sampling bagging. Each tree is trained on a random subset of 63% data using sampling with replacement. Remaining 37% OOB data is used for error estimation. 2. Random feature selection and decision tree training. At each split, a random subset of features, m is the square root of m for classification, m is divvied by 3 for regression, is chosen. The tree splits using Gini index classification or MSE regression. 3. Aggregation of predictions. Final output. For classification, majority voting. If we have T trees, each predicting a class CE, the final class is determined by, for regression, averaging predictions. For regression, the final prediction is the average of all tree outputs. This averaging helps reduce variance and improve accuracy. 4. Out-of-bag OBB error estimation. The 37% of samples left out during bootstrapping, OOB samples, are used to estimate model performance without needing a separate validation set. This serves as an unbiased performance estimate, helping tune hyperparameters. How is random forest different from other algorithms? Here's how it compares to some popular ML algorithms. Better than a single decision tree. While a single decision tree can overfit, random forest smooths out errors by combining multiple trees. More flexible than linear regression, it captures complex, non-linear relationships that linear regression can't. More reliable than naive Bayes. It doesn't assume features are independent, making it more suitable for real-world data. More accurate than KNN. Unlike k-nearest neighbors, it doesn't rely on distance metrics, making it faster for large data sets. How does the random forest algorithm work? Random forest follows these 4 key steps. 1. Bootstrap sampling. It randomly selects subsets of data to train multiple decision trees. 2. Feature randomness. Each tree is trained with a random subset of features to reduce correlation and improve generalization. 3. Majority voting, classification, averaging, regression. It combines predictions from all trees for more stable results. 4. Out-of-bag OBB error calculation. Helps evaluate model performance without needing a separate validation set. This combination of multiple trees makes random forest one of the most accurate and robust algorithms in machine learning. Why is random forest important in machine learning? Random forest is a versatile and powerful algorithm used for many ML tasks, such as classification, spam detection, sentiment analysis, fraud detection, regression, predicting sales, stock prices, and even climate trends. Feature selection, identifying the most important variables in a data set. But how does it help in the real world? Let's find out. Real-world applications of random forests. Medical diagnosis helps in detecting diseases like cancer based on medical data. Financial fraud detection identifies suspicious banking transactions. E-commerce recommendations suggests products based on browsing history. Image recognition used in facial recognition and object detection. Weather prediction forecasts climate changes and extreme weather patterns. Cons of random forests: computationally expensive, requires more memory and time to train, hard to interpret. Unlike a single decision tree, random forest doesn't provide clear decision paths. Not ideal for real-time predictions. Can be slower compared to simpler models. So that's a deep dive into random forest. We covered what random forest is and how it works, why it's useful in machine learning and real-world applications, its pros and cons. Want more hands-on ML tutorials? Let us know in the comments which algorithm we should cover next. Don't forget to like, share, and subscribe to Syntax Grid for more exciting machine learning content. See you in the next one.